Today we will do some more examples. For example, first we know that differential of d by dx of, suppose this is a constant, is equal to 0, or you can say c is any quantity which is not dependent, or you can say independent of x, not dependent of x. That means this c basically it does not depend on this x. Okay, so the second one, if you have d by dx of, suppose this is c into x, here c is simply you can say a constant or a quantity which is not dependent on x. Okay, so this will be equal to, what you have to do, you will first take out this independent quantity or this constant outside and write dx upon dx. It will be simply equal to 1, so we can simply write it as equal to c. We will see few examples related to this one. For example, suppose this pressure, suppose it is dependent on temperature and this k is some constant. Suppose this p is equal to kt. Okay, what we have to do, we have to differentiate it with respect to this temperature. We can say, we can write dp upon dt, okay, is equal to, as per this formula, suppose this k is, you can say, constant or independent of this temperature here. So we will write it outside and simply we will write dt upon dt. So you know this will be simply equal to k, dt and dt, it will go, it will be simply equal to k. Or if you put some more effort in this, you can rearrange this equation. This, suppose this is equation number 1, you can rearrange this, and that means you will simply take this t and to this side, so that means k can also be written as equal to p upon t. Okay, so this is the way how we can solve this type of question. Okay, now we will take one more example here. Suppose we have an equation of a straight line, y is equal to mx plus b. Okay, we have to, here b is, you know, this b, it is always a constant. Why? This is intercept, suppose, and suppose we have to differentiate it with respect to this x, so we will write dy upon dx, it will be equal to, this slope is always, suppose you can say this will be, this is independent of x, so we will take it out, so we will write dx upon dx plus this, if this is constant b and are independent of x or not dependent on axis, that will be simply equal to 0. So this can be simply written as equal to basically m. Okay, so one more, the formula we learned basically was the formula number third, d upon dx. I am taking the same simple formulas but trying to solve different equations which are basically are mainly used in physical chemistry. Okay, so n is any real number. We will take now examples based on this formula. The example number 1 we will take, suppose now this P is equal to K, K is some constant, upon V. So how to differentiate this equation? What we will write, we know a rule that if we want to apply this equation, it should be x raised power n form. So we will take, suppose we have to differentiate it with respect to this volume, that means dp upon dv. Okay, so what we will do, we will write it this in this form also, that means k v raised power minus 1. Okay, now this is very simple now. So this can be written as, this is k, we have to differentiate this now. So k will be outside, now d by dv of v inverse. Okay, so this will be simply equal to this, that means v raised power, it will be minus 1, k is there, so it is k and v raised power minus 1 minus 1. We are simply using this formula. Okay, so you can simply write it as minus k v raised power minus 2. Okay, or you can further simplify this and write in this form also, minus k upon v square. Okay, if you compare this equation to this one, suppose if you compare to this, it is minus k upon v square. So I can also write it as, it is not necessary, but sometimes an equation in physical chemistry is asked where we have to make substitutions. So we can write this equation also. Suppose we will write minus here. Okay, it is k by p is basically equal to p. So when we substitute k upon v is equal to minus p, okay, then there remains 1v. Okay, this is very simple. That means we can also write this dp upon dv, differential of basically this pressure with respect to volume, in terms of this. If we have this type of example, it is just an example to make you understand that how an equation is transformed into other equation or using a first differential of that equation. Okay, now if we want to take the second differential of this equation, suppose we have now dp upon dv is equal to, it is equal to basically this much, minus k upon v raised power minus 2. This is first differential. Second differential is written in this way, d square p upon dv square. This is basically, that means this is basically d upon dv of actually this dp upon dv. Okay, this is one and the same thing. That means I have to differentiate it two times. Okay, this should be well understood from now onwards. Okay, so what you will do, you will first write this minus k, because this much is independent of v, we have to write it outside, so we will keep it here. Now we will differentiate this v raised power minus 2, it will be x raised power n type, so it will be minus 2 v raised power minus 2 minus 1. So this can be written as, you take this minus and this minus here, it will be plus then. Okay, that means it will be simply plus 2 k, and this will be v raised power minus 3. Okay, or you can simply write this in this form also. So what we have done, we have simply used this simple formula. Okay, now we will take few more examples so that you can understand this fully. Suppose this is P now. We have, suppose, volume is equal to, you know, volume of a sphere 4 by 3 pi r cube. So suppose we have to differentiate this with respect to this radius. How we will write? dv upon dr, it will be equal to, this much is constant or independent of this r, so you will write it as 4 by 3 and pi. This will be here. Now this is r cube. What you will write? You will simply write it 3 r raised power 3 minus 1. So this will be equal to, you can further simplify this. This 3 and 3 will go, it will be 4 pi and it will be r square. So the first differential of volume with respect to radius, if this volume is equal to 4 by 3 pi r cube, will be equal to 4 pi r square. Okay. Now we will see one more example. Suppose we have kinetic energy is equal to 1 by 2 m v square. What we have to do? We have to differentiate it, this kinetic energy, with respect to this velocity. Okay. So it will be equal to, this much is independent of v, so we will write it here 1 by 2 m, and it will be again x raised power m, we will write it 2 v raised power 2 minus 1. So we can further simplify this 2 and this 1 is 2 in numerator, other in denominator, this will go, so it will be equal to m, and v raised power 2 minus 1 will be simply v. That means this first differential of kinetic energy here with respect to volume will be equal to this much. Okay. Okay, we will take one more example. Here, suppose fourth example, ln of P is equal to minus delta H, change in enthalpy suppose, divided by R, gas constant, temperature, plus C. C is simply some constant, where basically this delta H or this gas constant and C are constants. Suppose question is like this. What we have to do, we have to suppose differentiate it with respect to this temperature. How we will write the ln of P with respect to dt, it will be equal to. So as per this, delta H, R and C are constant. So this much, this is constant, or you can say independent of this temperature, you can first write it outside. Minus delta H upon R. Okay. Now, what about this T? We will write it in this form, x raised power n form. That means T raised power minus 1 with respect to T. We have to differentiate, plus differentiation of simple constant C. So here C is also constant, so it will be 0. I will not write it as dc upon dt. That is simply when understood that it is constant, it will be simply equal to 0. So this can be further simplified into this will be minus here. Minus is already there. If you take this minus to this side, so it will be plus. Okay. Then delta H R, this T raised power minus 1. We are basically differentiating this. So it will be minus 1, T raised power minus 1. Okay, I will write that first so that you will understand. So I will differentiate this one. It will be minus 1, T raised power minus 1 minus 1. Okay, so it is now very easy. Minus 1 and minus, it will be plus. You can write it delta H upon R, T raised power minus 2, or simply in this form also, R T square. So the ln of P with respect to this temperature is basically equal to this much. Okay. One more example. Example number 5th. This is very easy. Suppose radius is equal to under root of A. Now you have to suppose differentiate it with respect to A, this capital A. How you will write? We will first simply write this y is equal to x raised power n form. That means it will be y raised power 1 by 2. Okay. So now what we have to do? We have to differentiate it suppose with respect to this A. So it will be equal to, very easy, you can solve this 1 by 2 T raised power half of minus 1. So you can write this in this form. So it will be equal to 1 by 2 A raised power 1 minus 2 upon 2 is equal to 1 by 2 into A raised power minus 1 by 2. I am writing the full steps, otherwise I can directly solve this so that you will understand. In the future video lectures or video classes, you have to practice these very small questions so that we can go forward in this to understand the bigger equations. Okay, so now we will try to remember this also, that d by dx into sine of ax. Suppose this a is here constant, something constant. How you will differentiate this? It is, you have to remember this, it will be equal to a, and this sign will change into cos. But again you have to write ax, very important here. This a is here some constant. First write that outside. Okay, then cos, then again this function what is there. I will write where a is a constant. Now examples based on this one. The first example, suppose psi is equal to, you will, suppose I am writing here a wave equation, something like that, a sine n pi x upon, you will encounter these equations in quantum chemistry. Okay, so try to remember here how to solve these equations, or how to take differentials of these equations. Suppose if we have to differentiate this with respect to x, so we will write d psi upon dx is equal to, if you compare this to this one, this a, it is already some constant, we will write it first, so we don't have to do anything with that. Now if you focus on this part here, and if we compare this part to this sine ax, okay, so you will find this n, suppose n, pi and a, it is some constant. Okay, so what you will write, you will first take this constant outside, so we will write here n pi upon a, and then this sign will change into, because we are differentiating this sign, so it will change into cos, and write the full function what is there, cos n pi x upon a. Okay, so which formula we have used? Simply this, d by dx of sine ax will be equal to a cos ax. This is a here, this much is a, this is cos here, and this is ax. Okay, this whole thing, that means it should be basically a constant term there. These can be one or two or three, more than three items there, but they will be constant, and you have to differentiate in this way. Okay. We will take one more example so that you will understand this. Suppose y is equal to a sine 2 pi nu t, okay, where pi and this nu are constants. So it is already given in the question that this pi and nu are constants. So again we have to differentiate it with respect to, suppose this small t. So dy upon dt, it will be equal to, a is independent of t, we will first write it as, we don't have to do anything with this. This sign, now this sign 2 pi nu t, we have to compare it is sine ax. What is a now here? Constant. Pi is constant, nu is constant, 2 is already a constant. So it will be simply, we will write it here first, 2 pi nu, and this sign will change into cos. Okay. Cos, then 2 pi nu. This will be there. Okay. This is very easy. Only you have to remember, if you have this type of differential here, then how to solve this. The fifth one, we can take the reverse of the above one. That means we have cos of ax, suppose it will be equal to negative of a sine ax. Okay. A is what? A is a, here a is a, this a constant, simple constant. Now we will take examples based on this formula. Example number 1. Suppose already a first differential of, suppose we will take psi. Suppose d psi upon dt. First differential is already given. So a n pi upon a cos of n pi x upon a. Now what you will have to do, you will have to simply solve this part. Okay, so we will write the second differential as d square psi upon dt square is equal to, here this a is constant and pi upon a is already a constant. We will not do anything with this, we will directly write it, n pi upon a. Now we will focus on this thing, that means this part, cos of n pi x upon a. We will simply compare it with this cos of ax. Here n is constant, suppose pi is already a constant and a is also constant. That means in this much is constant. Okay. Suppose this much is constant. Now what we will write? We will write first n pi upon a. Okay. Then cos will change into sine, but negative of sine, we will write negative here. Negative, then n pi x upon a. Okay. So one more example we can take. Suppose y is equal to a cos 2 pi nu t. Now what we have to do, we have to differentiate dy by dt with respect to this t. Okay. So what we will do, we will simply write this as a. Okay. Now we will focus on this cos a, and this is suppose x. So first we will write it This way it will be first 2 pi mu, suppose this is constant, cos will change into sine but negative. From the formula you can see, and 2 pi mu. Okay. Now the sixth one, but you have to, I will give you one more formula, d by dx of e raised power ex. You know differential of e raised power x only is directly equal to ex, but if you have some constant, multiply to this x term, this constant, is some constant. How you will differentiate this? First, write this a, this constant term in front, and then write e raised power ax again. Simple. Where a is a constant. Okay. Now also we will take examples. Suppose example number 1. Example number 1 is, suppose this is capital phi is equal to a, some constant, e raised power iota m, and this is small phi. Okay. Where this capital A, iota, and m are constants. In quantum chemistry, this iota is basically equal to under root of -1. So you will remember this value. This iota is basically equal to how much? Under root of -1. How to differentiate it? So suppose we have to differentiate it with respect to this small phi. So we will write d, this capital phi, upon d small phi. It will be equal to, a is already there, we will write a. Using this equation, here it is given I is constant, m is constant, a is already a constant, we have written this outside, so it will be a. Compare this to this formula. So what we will write? We will write it first, Im. Okay. Then e raised power iota, not I, but iota m and p. Now suppose you have to differentiate it one more time, that is simply called the second differential. So we will write that also. The same procedure you have to apply if you want to differentiate it second time. Now for this is already a constant now, so I will write it first, iota m. Okay. Now again I have to differentiate this much, so it will be equal to, again this is e raised power ax again, so I will write iota m and e raised power I m iota I m phi. But you can write this in more compact form as, it will be suppose a, this is under root of -1, this is iota, suppose this is iota square, it will be under root of -1 whole square. Okay, so this square and root will go, it will be -1. So instead of writing iota square, I can write
Now, for the first I write this step iota square m square e raised power iota m pi. Okay, this iota square will be simply equal to minus 1. I will simply write the minus in front of this. So this will be equal to is there a m square e raised power iota m and phi. Okay, now if you compare this equation, that means capital phi basically, this one, this capital phi is basically equal to a e raised power I m phi. That means a and this e raised power I m phi, iota I m phi, that is small phi, is basically equal to capital phi. That means you can also simplify this into I here m square. Instead of writing a e raised power iota m phi, I can write simply capital also. Okay, so this is not necessary, but sometimes an equation will be given and you have to introduce the value and to get the local equation. So that means the equation, first equation from which you have started, you can write that in this form also. That means I have written this equation in second differential form and in capital phi term. So very simple. One more example I can take. That means suppose this A is equal to A naught A raised power minus K and capital T. Here we have this A naught and K. Okay, a small k are basically constants. Now we have to differentiate it dA upon with respect to this. Suppose capital T, I can write small t. It is up to you. It is just an example. Suppose this is small t, so it will be with respect to t. You can, this is a constant. First write this one. Then it is e raised power a x. Okay, a is here. And then highlight this. A is simply here minus k. So what you will do? Write first minus k into e raised power minus kt again. Okay, or no correct form, minus will be outside, a naught e raised power minus k. Okay, this is how a chemistry question basically is solved using the first differential or second differential. Second differentiation, what we are basically doing. Okay.